Welcome to Get Your FRQ On. This question is from 2009. It is question 4, and it is not calculator active. In the question stem, we are given two functions and the graph of the two functions, and the region bounded by these two functions is named R. In part A of the question, we are asked to find the area of the region R. So if you look at the graph, the endpoints of integration would be x equals 0 and x equals 2. Right? And also you can tell from the graph that for all values of x between 0 and 2, the graph of y equals 2x is above the line, the graph of y equals x squared. So y equals 2x would be our upper function, y equals x squared would be our lower function. So the area of region R can be found using the integral from 0 to 2 of 2x minus x squared dx. Now notice this is not a calculator active question, and you do have to evaluate this integral, which is fine. You should be able to do that once the AP exam comes around. You should be well versed at finding antiderivatives for polynomial functions and applying the fundamental theorem of calculus. So finding the antiderivative of 2x minus x squared, we're going to get 1x squared minus 1/3 of x cubed, and we need to evaluate that at 2 and 0. 2 squared is 4. We get 4 minus 8/3, and then if I evaluate that at 0, I'm just going to get 0 for both terms. So we get 4 minus 8/3, which is just 4/3. So the area of region R is 4/3. In part B of this question, we are told that R is the base of a solid, and for this solid, cross-sections taken perpendicular to the x-axis are given by an area function a of x. Find the volume of this solid. All right, we are given that the area of each one of these cross-sections perpendicular to the x-axis is given by this area function a of x equals sine of pi over 2x. So that's just an area function. The volume would just be the integral of that area function. So if I want to find the volume of the solid, I can just integrate my a of x function from 0 to 2. So the volume of that solid would be the integral from 0 to 2 of a of x dx, which is sine of pi halves x dx. And again, this is not a calculator active question, so you would be expected to find the antiderivative for sine of pi halves x on your own. All right, that was going to be negative 2 over pi times the cosine of pi halves x, and our bounds of integration are 2 and 0, so we're going to evaluate at 2 and at 0, and we get negative 2 over pi times negative 1 minus 1, which is just negative 2. Negative 2 times negative 2 is positive 4. The volume of the solid is 4 over pi. In part C of this question, R is again the base of a solid, and this time we're told that cross-sections perpendicular to the y-axis are squares. And then we are asked to write the integral for finding the volume of this solid. We do not have to evaluate the integral, but we do have to write it. All right, now since cross sections are being taken perpendicular to the y-axis, it makes more sense to solve the given functions for x as functions of y as opposed to leaving them as functions of y. In fact, I think we're going to need to do that. So my two functions, y equals 2x, if I solve that for x, I get x equals 1/2 of y. And if I take y equals x squared, I'm going to have x equals the square root of y. All right. And if you can picture what this graph will look like, in fact, based on the original graph, the square root of y function will be above the function y over 2. And then we also need to reinterpret our bounds of integration. Now we need to use the y-coordinates for the points of intersection. So my lower endpoint would be a equals 0. My upper endpoint would be b equals 4. And so the integral that would find the volume of this solid would be the integral from 0 to 4 of square root of y minus y over 2 squared.